I had a plan. I want to be very specific about that. Not a rough idea. Not a list of things I thought I should probably get around to buying. A plan. Spreadsheet. Every hour of the 72 hours mapped out. Calorie budget. 2,200 per day, pre-calculated per food item. Water budget. 2.5 litres drinking, 1.5 litres cooking and hygiene per day. Power budget. Watt hours available, watt hours per device, draw schedule to keep the battery bank above 30%. Equipment tested, all of it. The flashlight cycled. The stove lit 3 times to confirm ignition. The water filter flow tested at room temperature. The plan was solid. I was confident in the plan. The first surprise hit at hour 11. I'm going to walk you through every hour. This is episode 17. Last episode I built the plan, the full $500 off-grid system, sourced, budgeted, documented. If you haven't seen that, the link is in the description. This episode is the test. Same system, real conditions, no safety net. The rules were simple. No grid power, no municipal water, no internet, no food deliveries, no calling anyone for help. 72 hours, starting at 6 p.m. on a Friday. I documented everything. Hourly log, paper, written by hand, because obviously the phone was staying off the charger. Everything you are about to hear is from that log. Let me tell you what good looks like first, because the first 6 hours were good. Hour 1. I killed the grid breaker at exactly 6 p.m. The battery bank had been charging all day, 94%. The LED lantern came on. The camping stove lit on the first click. Dinner was the first pre-packaged meal from the rotation. Rice, lentils, canned tomatoes. Cooked in 12 minutes. Ate it. Washed the pot with the first 500 milliliters of my daily hygiene water allocation. Everything by the plan. I wrote in the log, quote, _0__. Hours 2 through 4. I used the time productively. Read a physical book, paper, no screen. Did a full inventory count against my spreadsheet. Everything matched. Battery bank at 88% after running the lantern for 3 hours at medium brightness. Right on the power budget curve. I noted the temperature. 17 degrees Celsius inside. No heating needed. I wrote, quote, _1__. Hours 5 and 6. I went to sleep. This is the part of the plan I was most skeptical about, actually. I am not someone who sleeps well in unusual conditions. But without screens, without the ambient noise of the router and the refrigerator hum, I was asleep within 20 minutes. Log note for hour 6, written after waking briefly to check. Quote 2. Here is why the first 6 hours being good matters. It creates confidence, and confidence is exactly what gets you in trouble. Hours 7 through 10 were the friction phase. Not failure, friction. The first friction point was the water. Not volume, I had the volume. Temperature. My pre-stored water had been sitting in 5-litre containers in the corner of the room. The corner that, it turns out, gets cold at night because it is adjacent to an exterior wall. Not dangerously cold, 11 degrees Celsius, but 11-degree water at 7 in the morning, for washing your face, for making coffee, that is a different sensory experience than I had accounted for. The plan said, quote 3, quote, the plan did not account for the psychological tax of cold water every single time. I noted it. Quote 4, quote, there is a concept in systems engineering called the comfort gradient. The gap between the conditions you tested in and the conditions you will actually operate in. Every system test I had done was at room temperature, in daylight, when I was not tired, when nothing had already gone wrong. That is not what real use looks like. Real use is 7 in the morning After interrupted sleep, slightly cold, slightly stressed, trying to do basic tasks that feel harder than they should. The water was fine. The conditions were fine. The gap between my testing environment and my operating environment was the problem. Friction point 2, hour 8, the stove. My camping stove runs on butane canisters. I tested the ignition, yes. I did not test the cook time at specific ambient temperatures. The kitchen was now 14 degrees Celsius, down from 17 the night before. Colder air means the butane canister delivers pressure less efficiently. My breakfast took 19 minutes instead of the 12 minutes from the plan. 7 extra minutes does not sound like a problem. In a real extended emergency, across multiple meals per day, across multiple days, that's a 20% variance in fuel consumption you did not budget for. I added a note. Cook time temperature dependency. Retest below 10 degrees. The butane pressure issue is well documented in camping literature. Every canister stove has a minimum operating temperature printed somewhere in the manual. The number for most standard canisters is around -9 Celsius for the basic butane blend, but that is the minimum for operation, not the minimum for rated efficiency. Efficiency degradation starts well above that threshold. At 14 degrees Celsius, the canister was operating at maybe 75% of its rated pressure. I knew this in theory. I had not translated theory into a tested cook time adjustment in my meal plan. Those are two different things, knowing a fact and building that fact into a practical procedure. Friction point 3, hours 9 and 10, the hygiene water budget. 2 liters a day for cooking and hygiene looked generous on the spreadsheet. In practice, when you are washing your hands after every trip to the bathroom, washing the pot after every meal, wiping down surfaces, the 2 liters was gone by hour 10. Hour 10 of day 1. I had 62 hours left. I was already looking at my reserve containers. Let me be specific about why the water budget failed here, because it is not a calculation error. The calculation was accurate for the average consumption I estimated. The problem was that I estimated based on household habits without the constraints I was operating under. At home, you use water without thinking. A quick rinse, a little extra to make sure, refilling the cup without measuring. The discipline of measuring every use, which is what a real resource constraint requires, revealed that my intuitive estimate of how much I use was approximately 40% lower than my actual use. The spreadsheet was right. My mental model of my own behavior was wrong. Here is what I want you to understand about friction points. Each one individually is manageable. You adapt, you slow down, you use less. But friction points are cumulative. They add cognitive load. Every small deviation from the plan requires a decision. Do I adjust the budget? Do I use the reserve? Do I change the schedule? By hour 10, I had made 6 small, unplanned decisions. None of them were disasters. All of them cost mental energy. And mental energy, I was about to discover, is the resource your spreadsheet cannot measure. Hour 11. 2:14 in the morning. I woke up. I needed to use the bathroom. Standard situation. I reached for the flashlight on the nightstand. The tested, reliable, fully charged 2 days ago flashlight. I pressed the button. Nothing. I pressed it again. Nothing. I pressed it 4 more times in increasing frustration, in total darkness. Nothing. I want to sit with this for a second before I give you the explanation, because the feeling in that moment is instructive. It is not panic. It is something more specific. It is the sudden awareness that you are in an environment you thought you controlled, and the control was an illusion. You thought you had prepared for this exact situation. You tested the equipment, you built the plan, and the plan is not working. And it is 2 in the morning, and you cannot see anything. Let me describe the room. No streetlight, I have blackout curtains. No router indicator lights, powered down. No appliance standby LEDs, everything off the grid. Real darkness. Not "it's dark in here" darkness. The kind of darkness where you genuinely cannot see your hand in front of your face. I knew where everything was. I had a mental map. The mental map was accurate. But moving across a room in total darkness, relying on a mental map, when your eyes are not adjusted, when you just woke up, when your backup light is in a bag across the room, that sequence took me 3 minutes and involved one collision with a chair I had not accounted for. The explanation, which I found with my phone flashlight, the phone I had kept off the charger but allowed as a true emergency backup, was straightforward. The flashlight had been left at 50% brightness on the nightstand, not turned off. The LED indicator that pulses to show battery status when the unit is off, a feature I had not noticed because I tested it in full daylight, had been drawing a small but continuous current for approximately 30 hours. The battery was dead, not because I forgot to charge it, because it had a parasitic drain I did not know about and did not test for. Tested equipment, fully tested. Failed because I tested the wrong thing. This is what I call a specification lie. Not that the manufacturer lied, the spec sheet probably mentions the LED indicator. I just did not read it carefully enough. I tested, does the flashlight turn on? I did not test, does the flashlight passively drain when off? 2 different tests, I only ran one. The immediate fix was simple. I had a headlamp in the kit bag. I found it, in the dark, by feel, because I had at least planned the kit bag location, used the bathroom, and then spent the next 40 minutes at the kitchen table with a candle, writing an expanded equipment testing protocol in my log. Not because I was in a good mood, because that is what you do when a failure surprises you at 2 in the morning. You write it down while the feeling of it is still fresh. The feeling of standing in complete darkness next to a useless flashlight is a more effective teacher than any gear review I have ever read. When I went back through my pre-test equipment testing notes, I found that I had done exactly what most gear guides recommend. I turned on each device, confirmed operation, turned it off, put it in the kit. What I had not done was leave each device in its stored state for 24 hours and then retest. That step would have caught the parasitic drain. It would have added a day to the prep process. It would have saved me standing in the dark at 2 in the morning, learning the lesson the harder way. I found my backup light, a small headlamp in the kit bag, used the bathroom, and spent the next 40 minutes writing an expanded equipment testing protocol in my log. Because that is what engineers do at 2 in the morning when a flashlight kills their confidence. They document. Hours 12 through 24 were the adaptation phase. This is where the test got interesting. The first 12 hours had been straightforward. Hours 12 through 24 required constant real-time adjustment. The water situation from hour 10 had not resolved itself. I had gone into my reserve on day 1, which meant the reserve was now a primary supply, and I had no reserve. I cut the hygiene water budget from 2 litres to 1.3 litres. This required a behavioural change. Cooking water and drinking water were now rationed separately, with careful measurement every time. What had been an automatic habit, fill the pot, cook the food, became a deliberate sequence. Measure, log, cook. This sounds minor. Do it every meal, every day, for 3 days. Hour 14. First real physical issue. Not a systems failure. My back. I had been sleeping on my regular bed, but without heating, the room was now 12 degrees, and I had not accounted for how much I normally rely on the electric blanket. The sleeping bag rated to 4 degrees Celsius was fine for temperature, but it constrained movement in a way that my back did not appreciate after 8 hours. I added this to the log under human hardware failure. Hours 17 through 20, the isolation variable. I want to be direct about this because it is not something most prep guides discuss honestly. By hour 17, I was bored in a way that was affecting my decision-making. Not dangerously bored, but the absence of all passive information intake. No news, no podcasts, no casual scrolling created a kind of mental restlessness that I was not expecting. I had planned intellectually engaging activities, reading, writing, reviewing the log, doing equipment maintenance. What I had not planned for was that intellectual engagement requires motivation, and motivation is harder to sustain when you are slightly cold, slightly physically uncomfortable, and mildly stressed from the accumulated friction of the previous 16 hours. I made 2 suboptimal decisions in this window. I used an extra 200 milliliters of water heating tea I did not need nutritionally, and I ran the lantern at full brightness for 2 hours instead of medium, costing approximately 12 watt-hours that were not in the budget. Small deviations, but they signal something important. When conditions degrade, discipline degrades with them. You do not need a major crisis to compromise your plan. You just need 17 hours of low-level friction. Hours 24 to 25. Day 1 checkpoint. I sat down with the log and did a formal audit. Battery bank, 61%. Target at 24 hours, 65%. 4% behind budget, the extra lantern brightness. Water reserve. Depleted on day 1, primary supply now being drawn at 1/3 over budget pace. Food, exactly on plan. One thing that worked exactly as designed. Morale, which I was tracking as a subjective 5-point scale, down to a 3 from a clean 5 at hour 1. I want to be honest about the morale number because it is the variable that determines whether any plan survives contact with reality. A morale of 3 is functional. You are doing what needs doing. You are not enjoying it, you are managing. In a real emergency, you do not get to choose the conditions. But understanding that your morale will degrade, and at what rate, and from what causes, that is critical data. Hours 25 through 48. Day 2, the fatigue layer. Day 2 introduced a variable I had technically accounted for in the plan, but fundamentally underestimated. Cumulative fatigue. Not sleep deprivation, I was sleeping adequately. Cognitive fatigue. By hour 30, every decision required more effort than the same decision on hour 6. Filling the water measurement cup. I had to think about it. Checking the battery bank. I had to remember why I was doing it. The automatic routines I had built during the planning phase were not yet automatic enough to survive reduced cognitive load. I want to put a number on this. In software engineering, there is a concept called cognitive load, the total amount of mental effort being used at any moment. Under normal operating conditions, your cognitive load budget is mostly empty. You have capacity for complex decisions, creative thinking, problem solving. Under accumulated friction, multiple small deviations from plan, each requiring a small decision, each adding a small stress response, your cognitive load budget fills up. Not with a single dramatic event, with dozens of trivial ones. By hour 30, I was making simple decisions. What to eat, when to sleep, how much water to use, at cognitive cost that should have been near zero. The budget was depleted by the accumulated weight of the previous 30 hours. This is a concept from disaster recovery planning that I should have applied more rigorously. Runbook fatigue. A runbook is a documented procedure for handling a system event. You write it carefully, you test it, but under real incident conditions, at 3 in the morning, after 16 hours on call, even a clear runbook requires more effort than it did in testing. The answer is not to write better runbooks. The answer is to simplify the procedures until they can be executed at 50% cognitive capacity. My procedures were not simplified enough. I had a 12-step morning routine documented in the plan. Check the battery bank, log the reading. Check the water level, log the reading. Prepare the meal, measure the water for cooking. Measure the water for drinking, log both. Clean the pot, log the cleaning water used, total logged, compare to budget. 12 steps, all of them reasonable, all of them individually simple. On day 1, that sequence took me 11 minutes. On day 2, it took 23 minutes. Same steps, twice the time. Because each step now required a moment of recall. What comes next? What am I measuring? Where is the log? That had been nearly automatic on day 1. The fix, which I worked out during the test and will implement in any future run, is maximum 4 steps in any routine. Not 12, not 8, 4. The 4 most critical checks combined into a single observation if possible. Everything else either automated into a default behavior or eliminated entirely. Hour 36, failure point 3, the water filter. I had tested the Sawyer squeeze filter's flow rate before the test. Good flow, no issues. What I had not tested was the filter after the water had been sitting in the storage bags for 36 hours at fluctuating temperature. The rubber bite valve on one of the squeeze bags had developed a slow leak, not at the filter connection, at the bag seam. I lost approximately 400 milliliters before I noticed the drip. 400 milliliters is not a crisis, but finding a slow leak from a seam failure, tracking it to the source, moving the remaining water to a backup container. That sequence took 40 minutes and produced a stress response that was disproportionate to the actual loss. I logged it under __, quote _ 10 __. The Sawyer bag is not designed for indefinite storage under pressure. I had treated it as a storage container as well as a filter input. That is 2 jobs for one piece of equipment with a seam that was not engineered for continuous static pressure. Engineering mistake, not a product failure, a use case failure. I was using it wrong. Hours 40 through 48, the comfort ratchet. This is what I'm calling the psychological phenomenon where you stop noticing degraded conditions because they have become the new normal. By hour 40, I had stopped noticing the cold water. I had stopped noticing the slightly sore back from the sleeping bag. I had stopped noticing the extra time each meal took. The discomfort had been absorbed into the baseline. On one hand, this is adaptation. On the other hand, it means you stop tracking degradation until it becomes a crisis rather than catching it early. Day 2 checkpoint at hour 48. Battery bank 38%. Target 42%. 8% behind total budget now. Water. I had implemented strict rationing and was holding at budget but with 0 margin. Food. Still on plan. The food system worked perfectly for the entire 72 hours, I will say that clearly. Pre-packaged, pre-measured rotation system, exactly as designed. Morale, 2.5. Hours 48 through 72, the final stretch. Day 3 introduced failure point 4, the most interesting one. Not a gear failure, not a resource failure, a planning failure at the system level. I had designed the 72-hour test as a closed system. Everything I needed was inside the house. What I had not accounted for was a minor medical situation, a headache that escalated to a migraine by hour 52. I had ibuprofen in my kit. The ibuprofen was fine. The issue was that I had allocated exactly 1 day's worth of ibuprofen, 4 tablets. A migraine requires 2 tablets, then 2 more 4 hours later if the first dose does not fully resolve it. My headache required the full 6-tablet protocol over 8 hours. I had 4. The migraine passed. I am not describing a medical emergency. I am describing a planning assumption that turned out to be wrong. I am a healthy person who will not get sick during a 72-hour test. That assumption was not tested. It could not be tested in advance. But it reveals a category of failure that no equipment audit catches: the human system variable. You plan for gear failure. You plan for resource consumption. You do not plan, and cannot fully plan, for what your own body does under sustained stress over multiple days. Hours 55 through 65, the adaptation payoff. This is the part I did not expect. After the migraine cleared, something shifted. The friction points that had been accumulating since hour 7 had produced something useful. Genuine routine. I knew exactly how to manage the water measurement in minimum time. I knew the exact cook time for each item on the food rotation at current kitchen temperature. I knew how the lantern looked at 30% battery versus 40% versus 50% without checking the indicator. The system had worn grooves into my behavior. I was operating efficiently, not from the plan, but from experience. This is what 72 hours of living inside a system teaches you that no amount of planning can. The plan is a model. Experience is the system. Hours 65 through 72. I ran through the remaining time with declining anxiety and increasing calm. The battery bank hit 27% at hour 70, 13% below my target of 40% at end of test. The water situation was tight, but resolved without touching the reserve that had been depleted on day 1. I had adapted the rationing tightly enough to make it work. Food. Full rotation completed. The backup supplies had not been touched. At exactly 6 p.m. on Monday, I restored grid power and ran the hot water. I stood in a hot shower for 11 minutes. I then sat down with the log and started the failure analysis. Here is the updated failure map. Failure point 1. Parasitic drain on tested equipment. The flashlight at hour 11. This is the testing protocol failure. My equipment testing covered function. Does it work? It did not cover behavior. What does it do when you think it is off? Every piece of electronic equipment in a prep kit needs a parasitic drain test. Turn it off. Wait 24 hours. Check the battery. If the battery is below 95%, you have a drain. Map it. Plan for it. This test takes 1 day and requires 0 skill. It is the test I skipped because I was confident in the equipment. That confidence was the problem, not the equipment. The implication goes beyond the flashlight. Every battery-powered device in your kit has a self-discharge rate and a parasitic drain potential. Headlamps with LED indicators, radios with memory backup circuits, GPS units that maintain satellite lock in standby, power banks with display circuits that activate on bump detection. All of them drain. Most of them drain slowly enough that you will not notice over a day. Over 30 hours in a prep kit, or longer in storage, the drain matters. The fix is, know the drain rate for every device, build it into your storage rotation schedule, and test in situ before the test, not just at time of purchase. Failure point 2. Water temperature and psychological tax. Not a volume failure, a comfort failure. Water stored against exterior walls in cold weather becomes a daily friction tax that compounds over time. Storage location matters. Insulation of containers matters. These are not survival issues, they are endurance issues. And endurance determines whether you follow the plan or start improvising around it. There is a principle in long-duration mission planning, used in maritime expeditions, polar research stations, long-haul aviation, that comfort resources are not luxuries. They are reliability factors. A crew that is mildly uncomfortable, cold, or physically irritated will make more errors, will be slower to respond to developing situations, and will have lower morale at exactly the moments when morale matters most. My stored water was fine for survival. It was failing as a comfort resource. In a 72-hour test, this is manageable. In a 72-day extended situation, it would compound into a serious reliability issue. Failure point 3. Single-use container as dual-use storage. The soya bag, designed for squeeze filter input, is not designed for long-duration static pressure storage. Using it as both a filter input and a storage container created a seam stress it was not engineered for. The fix is simple. Purpose-specific containers for storage. Transfer to filter input bags only when filtering. 2 containers, 2 jobs. Redundancy at the component level. This is basic engineering practice, right-sizing components to their actual load requirements. I had underspecified the storage component by assigning it a job description that exceeded its design parameters. Failure point 4. The human system variable. Medical supplies planned on baseline health assumptions. Baseline health is not guaranteed. Every consumable medical item in the kit, pain relief, antacids, antihistamines, bandaging, needs to be calculated at 2 times the expected consumption rate. Not because you expect to be sick twice as much, because real conditions are not test conditions, and you are not a machine. I want to add a 5th finding here that I am not categorizing as a failure point because it is not a failure, but it is a finding that changes how I think about prep planning entirely. The food system worked perfectly, for all 72 hours. The reason it worked perfectly is that I had designed it with the most structural redundancy of any component in the system. Multiple meal types, pre-measured portions, no single ingredient that was critical to multiple meals. Rotation designed so that any individual item could be skipped without breaking the rest of the system. That design philosophy, redundancy, modularity, no single critical dependencies, is exactly what I applied to my server infrastructure for years. It worked there. It worked here. The lesson is to apply that same design philosophy to every other component in the system. The water system had a single critical path. The power system had a single critical path. The food system had multiple parallel paths. The food system was the only one that worked perfectly. That is not a coincidence. Here is the verdict on the $500 plan from episode 16. The food system worked, exactly as designed, for all 72 hours without modification. This is the highest reliability component of the system. The power system worked with a margin deficit. The battery bank performed as rated, but my consumption tracking was not precise enough to stay on budget under degraded cognitive conditions. The gap was 13% over 72 hours. In a longer event, that gap compounds. The fix is a simpler power protocol, not stay above 30%, but by noon each day you should be at this number. If not, cut this load immediately. Simple decision rule, no calculation required. The water system worked under rationing, but without margin. The original budget assumed comfortable consumption. Real consumption under friction conditions is different. The fix is adding a 15% buffer to all water budgets and storing all water against interior walls. The gear testing protocol failed. Not the gear, the protocol. Equipment needs behavioral testing, not just functional testing. The difference costs an extra 24 hours before any test. It is worth it. The human factor was not planned for adequately. No spreadsheet models fatigue, boredom, minor illness, or the compound effect of small friction points on decision quality. The fix is simpler procedures, fewer decisions, more default rules, less calculation under stress. I want to end with what I said in the hook. I had a plan. The plan was good. The plan was not good enough, because no plan survives contact with the reality it was built to manage. This is not a failure of planning. This is what planning is for. You build the model, you run the test, The test breaks the model. You update the model. The map is better now. It has 4 new failure points that were not on the original map. Those 4 failure points are now accounted for. The next test will find different failure points. The map will get better again. You do not find the real problems in a spreadsheet. You find them in the dark, at 2 in the morning, when your supposedly tested flashlight will not turn on. And if you find them in a test, in a controlled 72-hour exercise where the stakes are mild discomfort and a log full of notes, then you do not find them when the stakes are different. Run the test. Find the failure points. Update the map. That is the whole methodology. Next episode, what the 72 hours taught me that no prep guide covers. The things that are not on any equipment list. The variables nobody publishes because they are not products you can sell. Episode 18. Link in the description when it drops. Audit your assumptions. Start with the ones that feel most solid. Those are exactly the ones you have not actually tested.